What if I told you that there is a framework that makes it near impossible to write bad code? That's exactly what you get with NestJS. The NestJS framework achieved this by enforcing a very rigid code architecture. And as a result, you can build an application that is scalable, easy to test, loosely coupled, and makes it impossible to write bad code. At the end of this crash course, you'll have everything you need to start building a NestJS app, but most importantly, build it the right way. So in this video, I'll show you how to structure your code, 10 key concepts to ensure that you have solid foundations to build a Nest app from scratch. And to show you how everything fits together, we will be building a podcast API every step of the way for you to follow along. But first, I need to show you the NestJS secret weapon, and that's going to save you a lot of time. That secret weapon is the Nest CLI tool. The first thing the CLI can do for you is to create a Nest application. You can install the Nest CLI globally with npm, then you create the podcast app with the CLI new command. Once the app is created, you can start it in watch mode with the start dev command. If you send a request to localhost 3000, you will receive a hello world response. The CLI can do much more for you. It can create entire modules with CRUD resources. It can create test files, controllers, providers, guards, pipes, etc. But don't worry if all of those don't mean anything yet. We are going to go through each one of these in this crash course. So let's dive into the code generated, and we will start with the main file. The Nest Factory function creates our Nest app using the app module class, and the Nest app starts listening to the port 3000. Let's have a look at what's inside the app module class. If you have mostly used plain JavaScript, this will look a little bit strange. So we have an empty class, and before that we are calling a module function. That function is a decorator, and before we go any further, we need to address that straight away. If code feels like magic, it's simply because you don't understand it yet. In Nest, decorators are everywhere, and that's why I decided to explain them first. First of all, decorators are not magic, they are functions. But those functions can be applied to classes, methods, and even method parameter. A decorator will add extra functionalities to the class, method, or parameters they apply to. And some decorators will have extra parameters to control their behavior. And if we go back to the app module, we can see that the module decorator is applied to the app module class, and that decorator takes a configuration object as argument. I'll explain what that object is later on. And don't worry about the other files generated as well. We'll get back to them later. Now that you know what decorators are, let's talk about the code structure. NestJS is like a severe parent that knows what's best for you. You just need to obey the framework and things will be fine. A strong recommendation is to structure your code in modules. So every NestJS app has one root module, only one, and that root module can use other modules, which themselves can depend on other modules, and so on. And that creates an application graph. So each module will encapsulate a set of related capabilities, and it can be a particular feature or a domain. So in our app, the app module is our root module. We know this because it's the class used to create the app. So our Nest app will have an episode module, a topics module, and a config module. But how do you create a Nest module? So you can use the secret weapon, the CLI. So you run the command nest generate module, and an episode module file will be created inside the episodes folder, and you can do the same to generate the topics and the config module. Each module has a module decorator. If we open the app module, we can see that all the modules we've generated with the CLI have been added to the import property. This means that the app module uses all those modules. If we remove the config module from that array, the config module is no longer part of our application. It's not part of the application graph anymore. What you could do is import it in the episodes module, and now it's part of our app again. and I can even import it in the topics module, and we end up with the following application graph. The imports property is what defines how modules are organized. And what we can have inside the module is classes. If your app has no controller, then your app can't handle any incoming requests. Controllers are the entry point for most NestJS app. A controller is simply a class that is decorated with the controller decorator. And if we open the app controller file, we can see that it has a controller decorator. To create a controller inside the episode module, you can run the nest generate controller command. And you can see that the generated controller takes a string as parameter. And that string is the root path managed by the controller. But how do we know that the episode controller is part of the episode module? If we go in the episode module file, we can see that the CLI has added the new controller in the controllers list. The controller classes have methods to handle requests. For example, you can add a findAll method to the episode controller. And for now, it just returns a string, but we will change that later. To indicate that it handles the get request, we decorate it with the get decorator. It's the same principle for handling posts, requests, and so on for any other HTTP method. The method decorator accepts a string as parameter as well, and that string argument can be a nested root path. Later, I'll show you how you can set URL parameters with that as well. Let's say that you want a handler to return featured episodes, and you want that handler to be called for the root episode /featured. You can add a get decorator to that handler and featured as an argument. As you can see, decorators are everywhere in NestJS. So far, we've used class decorators and method decorators, but there is another type of decorators that we haven't used yet. Some handlers will need access to the URL parameters, queries, the request body, or even the entire request object. For example, you can add a sort parameter to the findAll method and prefix it with the query decorator. You can do the same thing for the body and request and params as well. If we add a handler to the get an episode by ID, and you want the ID to be a URL parameter, you add it as a parameter of the method, but you also need to add it to the HTTP method decorator with a colon character. Basically, you tell NestJS what you want by using decorators, and the framework does the heavy lifting for you. And by the way, you can even create your own decorators, but that's a little bit out of scope for this crash course. With this simple implementation of the controllers, you can send requests to the root you've defined. You can send a request to get all the episodes. You can send a request to get featured episodes, create an episode, and find an episode by ID. So feel free to implement an update and delete endpoint with the put and delete HTTP method. So our handlers are doing a great job at receiving the incoming request and returning a response to the client. But there is a big piece missing. So instead of returning mock responses to our client, our handler needs to delegate the real work of finding and creating the episode to a service. And services are part of a bigger NestJS family, the providers. Nearly everything in NestJS is a provider. Providers are classes that have the injectable decorator, and this means that they can be, injected. So to be more precise, they can be injected in other classes, but we'll see what that means as we create the episode service. First, you can create the episode service using the generate service CLI command, and on top of creating the service file and the test file, the CLI will automatically add the new service to the providers list in the module. This part is crucial if you create your providers manually, because you need to make sure to add them to the providers list, otherwise they can't be injected in other classes. So that's very important. I have prepared the service class with a few basic methods to manage the episode data. So we have a find all method, find featured, find one, and a create method. All are fairly simple, they just read or update the episode array, and I have declared them as asynchronous even if there is nothing asynchronous going on with this implementation. That's because we use an in-memory array for this demo, but in a real app, you would most likely store and retrieve the data asynchronously from a database. You can see that the create function takes a DTO object as parameter. I'll tell you a little bit more about that when we look at the pipes. But what is the point of having a service if it's not used anywhere? And now it's time to talk about another pillar of NestJS, dependency injection. So what comes to your mind if I say solid? Maybe something about clean code, best practices, or just an annoying acronym that you have to remember for interviews and instantly forget once you get the job. But don't worry, I'll spare you all the theory and we'll jump straight away on how the dependency injection part of the solid principle works in the NestJS context. But before we go any further, let's take a step back and look at what's in our app so far. We have a root app module. So the root module imports the topics module and the episodes module, and both those modules import the config module. We will just focus on the episodes module, and the topics module and config module are just here for the example. Inside the episodes module, we have an episode controller and an episode service class. The controller needs to use the service class, but in NestJS, you don't create an instance of the service inside the controller. The service class will be injected in the controller by NestJS at runtime. One way to tell Nest to inject the service in the controller is to add a constructor to your class. Then you add a private parameter with the type episode service. When you do that, NestJS will take care of creating an instance of the service and inject it in the controller class. And that's dependency injection in NestJS. So you create a provider class with the injectable decorator, and you make sure to declare them in the module, and you inject the provider in a class constructor, and the framework takes care of wiring things up at runtime. Now, instead of returning strings, the handlers can call the injected service methods. So for the create body, I can replace that ugly any with the create episode DTO and call the service create method. But what if I want to inject a service from another module? Let's say a configuration service inside a configuration module. You can quickly create a config service using the CLI. And by the way, you can even use shortcuts with the CLI. For example, here I'm just using the shortcut G for generate and the shortcut S for service. And that way you can even save more time. And as usual, the CLI will add the service to the providers list in the module. But this time you need to add one more thing. You need to add the config service in the exports list. You then need to make sure that episode module imports the config module, which is already the case for us. And finally, you can inject the config service in the episode controller. So we are not going to use the config service, but this is just for the example. And as a matter of fact, you can even inject the config service in any class inside the episode module now. For example, you could inject the config service inside the episode service class. You don't even need to understand what dependency injection is to use it. You just follow the pattern and you get the benefits anyway. So that's one of the good things about Nest. It tricks you into writing well-organized code, and it enforces everyone in your team to write the same type of code. And a major benefit of adopting this pattern is that it makes your code easier to test. So far, the CLI has created test files for us, but we have been completely ignoring them. So let's have a look at what's inside the generated test file for the episode controller. Nest provides testing utilities to create a module, and we can extract the controller instance from that test module. The generated code simply checks that the wiring is happening correctly, and if you run the test, you will see that it will fail. That's because the test module builder doesn't know how to inject the controller service and the config service defined in the controller. So you can import the config class and provide the episode service class. And now if you run the test will pass. That's because the episode controller class dependencies can be correctly injected. But the interesting part is that when you create the test module, you can pass mock provider instead of using the actual episode service. We can create a mock object with the same signature as the class and provide that object using the useValue property. In order to test the find_one handler, you call the controller instance method and you test that the value returned is the expected value. You can even mock the service find_one function. When working with mocks, it's usually a good idea to reset them before each test. So you can now mock a return value and test that the controller handler returns the mock result. You can add another test to ensure that the controller calls the service with the correct values, and you could implement all the other unit tests for all the handlers in the same way, and you can also apply the same approach for testing the other classes generated, all the other services and controllers. And this is how dependency injection improves testability. You can test a class in isolation because you have full control over what's injected in that class. So now let me show you how to go one step further and test for a negative scenario. So let's move all our previous tests inside a describe with when episode is found and create a new test scenario for when an episode is not found. You can mock the returned value to be null to simulate the case where the episode is not found. This time we want the handler to throw an error, but with our current implementation, the test will fail. To fix this, we can change the handler's implementation. So we can add a condition to throw an error if the service does not return an episode. And now if you run the test again, it should pass. But if you throw an error in the request handler, what does the client receive as a response? So let's find out by having a look at how Nest handles errors and how we can improve our code to return a useful response. If you want to be mean to front-end developers, just return unusable errors. But even if you absolutely don't care about error handling, Nest is going to be helpful regardless and return a 500 internal server error response if there is an unhandled error during the request handling. But we can do much better than that. NestJS has built-in support for standard HTTP responses. You can use the HTTP exception class and pass a message and status. Or you can even use one of the predefined class such as NotFoundException, which will return a 404 status. Or you could use a forbidden exception, unauthorized exception, etc. When you throw a HTTP exception or any of the other standard HTTP exception class, NestJS is smart enough to convert that into a usable JSON response with the appropriate status code. But that's not all. If you want to, you can customize the way errors are handled, and you can customize that behavior by adding exception filters. So that's a bit more advanced, but it's just important that you know it's a possibility. So Nest provides a great level of standard behaviors that help you get started, but it's also extremely flexible. You can customize a lot of things and hook into the request lifecycle in different ways. For example, you can control what happens before a root handler is even called. We know that we shouldn't trust incoming data from clients, but instead of checking the input in the handler's logic, NestJS has pipes. Pipes can be used to validate or even transform the input data before it's handed over to the root handler. If we add a new query to limit the number of episodes returned, we can use the parseInt pipe, and this pipe will validate that the query parameter is present, but it will also validate that it's a valid integer. If you want to make that limit query optional and use a default value, you can use the default value pipe. There are several built-in pipes you can use, but if you can't find what you need in the built-in pipes, you can create your custom pipes. And for that, you create a provider class that implements the pipe transform interface. I have prepared a custom pipe, the isStrictlyPositive pipe, and as you can see, it implements the pipe transform and has a transform method. So if the value is inferior to 0, it throws a bad request exception, otherwise it just returns the value as is. So now you can use that custom validator by adding it to the limit query. But it even gets better. Usually, most validation and transformation concerns are about the request body in a post or put request. And for that, you can leverage the power of the class validator and class transformer NPM libraries. You can install the two libraries with NPM. And if you go back to our service, you remember the DTO class we had in the create function. So let me show you how that's super useful. By the way, DTO stands for Data Transfer Object. You can decorate the DTO properties with the validation decorators from the class validator library. So you can add a isString to the name property. You can add isBoolean and isOptional to the featured property. Once you've done that, you can go back to the controller and add the built-in validation pipe class as the argument to the body decorator. NestJS can automatically apply the validation rules defined through the class validator decorators. You can also leverage the power of the class transformer decorators. And if you want to add a date property to the DTO, you can add the isDate decorator for the validation. But if you send a request with the published@, property, the validation will fail because there is no date type in JSON. You have to send the value as a string. To fix this, you can add the type decorator to transform the input value into a date instance. And now if you send the request, the validation will pass. And the input value received by the request handler will have an object with a valid JavaScript date instance. But what if we don't even want to accept the incoming request in the first place? For example, the client is not authenticated. Access control is a critical part of most applications. In Nest, you can add guards to your controllers and request handlers method for that. A guard is a class with the injectable decorator and that implements the canActivate interface. So the guard class needs to have a canActivate method, and the canActivate method returns true to authorize access and false to reject the request. The method takes an execution context as parameter, and from that context, you can extract the request object and apply some validation against the headers or any other request property to decide whether or not to accept the request or reject it. You can, for example, check that the request header has a valid API key. But that's just the first part. Now we need to apply that guard. So you can apply the guard on a controller class with the useGuard decorator, and you pass the guard as an argument to the decorator. And this means that our guard is controlling access to all root of this controller. So if you send a request to any root of that controller, you'll need to pass a valid API key. Otherwise, the request will simply fail and will be rejected. But you also have the possibility to only apply the guard to some handlers. For example, we could only restrict the access to the create endpoint. And to do that, you just copy the guard decorator and you just apply it to the create handler. Now, if you send create request, you need to have a valid API key, but you can send requests to any other endpoint and access will be granted. There are some mistakes you can get away with, but you can't get authentication wrong. Even if Nest makes it easier for us, it's still up to us to implement it correctly. So I have barely touched the surface of authentication, but you can watch this next video to understand how to implement an entire authentication flow, and I'll show you how to authenticate users using username and password, issue authentication tokens, and control access to the restricted endpoints.